Hello, and welcome to another episode of Risky Business. Today, we are going to be continuing on with our implementing lines. Um, we had some technical difficulties yesterday, but hopefully, it goes better today. I know one of the problems was just that I was in the wrong directory with NeoVim, and so I had like 900 files loaded, and that's why it was really laggy yesterday. Okay, so now I think we also want to set the color of the line, right? So let's take a look at GeoColor. Okay, and we can set the alpha as well. I think I am going to want to try that because I have some ideas with that for when we're doing zooming. Oh, and I hear my dog barking, so I'm going to be right back. I need to let her in. So I'll be right back. I have returned. The dog has been let in. So, so I think we want to do the GeoColor 4. So wait, are these taking floats from 0 to 1? current color values are stored in floating point format. Okay. Although it says unsigned integer color components, when specified, are linearly mapped to floating point values, such that the largest representable excuse me, value maps to 1.0. So there are integer variants then. Interesting. So let's take a look at the actual signatures. So we care about the ones that are 4. So there's one that takes bytes, one that takes shorts, one that takes ints, one that takes floats, doubles, unsigned bytes, unsigned shorts, and unsigned ints. So if I'm understanding this correctly, if we do geocolor for UB, then we'd be specifying values from 0 to 255, which is how we normally think about color, right? So that seems like the one we'd want to try. So I'm going to just give that a try and we'll see what happens. So we are going to try like making some red lines, I guess, just to start out. So I am going to do GL color. What was it? For UB? Yes, for UB. And we are going to say 255 0 0 255. And then we are going to want to actually set some values here. Now, we don't have access to the view structure in this function. So when I was thinking about how we'd go about this, I was thinking we'd have access to screen center. And it looks like that's all we actually need is the screen center. Well, there is the canvas to raster business. Does that depend? So like canvas to raster conversions, they use the pan vector and the scale and the center and all that. But I don't think we're passing a view in. So is it like globally accessible? Is it like a global variable? I want to take a look at that. So I don't remember where that's defined. Canvas.cc. Okay, it's right here. Oh, we do pass the view in. So can we not do coordinate conversion in this particular function? Maybe we're implementing this in the wrong place. That's kind of the suspicion I'm getting now. Because if you look here, you'll see that this is the GPU render function, and we're not passing in the canvas view. So we pass in some things we need, like the view x, y, width, and height, but not the actual canvas view. So I don't think this is really the place to implement this. I think we want to find a better place to implement this. I mean, we could just change the signature of the function to pass in the view, but I don't think we're going to do that. So we have this render canvas, and I'm thinking maybe we want to do it here. So like, how does the GUI render then? Because I know there's GUI rendering that's happening after where I was implementing lines. So where is that? Yeah, see, this is rendering the GUI over here. So it's using a shader. So it seems like the position of the elements of the GUI and all that kind of thing is like pre-calculated somewhere else, and then this is just taking like the raw data that's prepared to be blit to the screen and doing the actual OpenGL pipeline with it. If I'm understanding the code correctly. So I want to step back a moment and go over this whole pipeline again. So we're calling that from render canvas? Or do I have that backwards? So here's clip strokes and update. Here is render canvas. Oh, so GPU render calls render canvas. So I think I want to take a look at the main loop. What was that in? Milton? I thought it was like a Milton.cc or something. Yeah, so here's update and render. So we're doing GUI stuff in here. And this is doing stroke stuff. So down here at the bottom is where we're doing the clip strokes and update and the GPU render. So I think we can't put it before GPU render because then it's going to render on top. Like everything that Milton is rendering right now will render on top of what we're trying to render. And if we do it after, then it's going to render on top of the GUI and stuff like that. So we are rendering in the right place. The problem is that we're rendering the wrong thing. Or I mean, we haven't calculated what we want to render, and we can't calculate what we want to render because of the current function signature of the GPU render, and I don't think this solution is changing the function signature. I think the solution here is to split it up and calculate what we need to render in the like update portion, and then have that. I guess that would be in the Milton state render data, right? And so it would just go through the normal render pipeline like that. I feel like that is the best option that we can do with the way it's currently structured. So that kind of constrains our implementation a little bit. We need to understand how render data works. So I guess we're going to take a look at that. Although I feel like we should test just rendering line like the code that we already have. We should just test that and make sure like that's working. And then we'll at least know that we're like rendering in the right place. So before that, I did notice that if we head over here to the GitHub repository, so if we look at the commit history here, we can see that Surge has done some interesting things. So what commit are we currently on? Deck 64. So we're on this one right here, hack EasyTab for multi-packet mod. So since then we've had updates to the EasyTab stuff, getting pen orientation going, stylus buttons on Windows, pen touch button on EasyTab Linux. So I feel like we should probably take a moment here and pull in the changes and get ourselves back up to date. So I'm out of date as well here. I made a organization for risky business. It's not like I'm not like putting it out there as like advertised yet because I don't have a little avatar on it yet. I haven't put a description, just little things like that, right? But I moved my repository, my fork of Milton over here. And so I need to update my remotes. So I'm going to say get what is it? Remote set URL. And you put the name first or second. I don't remember. I'm gonna try second. Nope, name needs to go first. Okay, and now we're going to get stash, and we're going to get pull surge master. And now I want to make a test canvas, because if we do anything horribly wrong, I don't want to corrupt our current canvas. So new Milton canvas, this will just be our test canvas. Now let's quit. And we're going to build Milton. So we're going to say make. And we can run Milton, and I just want to see here what kind of differences we have. So it looks like I still don't have pressure sensitivity, which is not surprising really, but I want to see. So pen orientation isn't working for me. I think that's true in general. Like the eraser button, I don't think it works with the driver I have right now. So that's okay. What happens when I press the button on the side? Doesn't seem to be a problem. I had some issues with that in the past, and I think Surge kind of fixed that for me. So that should be good. It looks like everything's working. Now we're going to pop our changes off the stash. So we're going to head back to hardware renderer.cc. So here is our thing. Now I'm just gonna say, like, let's go some amount of pixels down, like 30, or let's do 42 if we're gonna pick a random number. And then let's see, and we want the wait, no, this needs to be the Y. So the X is going to be 0.0, the Y is going to be 42, so 42 pixels down, right? And then the X on this one is going to be whatever the screen height is, and then, or the screen width, I mean, and then 42 down again. So, or I guess it's up, isn't it? Because GL has the y-axis flipped. But it doesn't matter. This is just a little hacky test here. So, or wait, we have a view X. So maybe we need to actually say view X plus. So let's do that. View X, and then view width. Or I guess it would be view x plus view width. And so I want to see if this works at all. So we're going to build that. Undeclared identifier depth test. So let's comment that out. So I don't see my line anywhere. So what did we do wrong? Maybe this is supposed to be 0, not view x. Nope, still don't see it. So I'm not sure what we're doing wrong here. Let's try the color F. Did not make a difference. Geodepth test, I will give that a try. Still no line. Now let's try that again, but with view X. Still no line. So why are we not getting a line? Let's try 0, and then instead of using this view, let's do the render data width. No, that didn't work either. Who knew drawing a line was so hard? So maybe we need to throw in a geo flush or something. So I have no idea what is going wrong. So let's study this pipeline some more. So let's take a look at some of these things that we're doing here. So GL viewport, let's take a look at that and just see what it does. So specify the lower left corner of the viewport and the width and height. So when we're drawing, are we drawing in relationship to the GL viewport? I feel like we would be, wouldn't we? Meaning we would want 0 and render width. And then let's take a look at GL scissor. Okay, we already disabled the GL depth test up here. But I don't understand why we're not seeing our line. So the color should be red. And I think it would just be like a 1 pixel horizontal line. I define 2 vertices. It's GL lines. The first vertice is 0, 42. So that would be 42 pixels up from the bottom of the screen and all the way on the left. And then the second vertice should be all the way on the right at the same height. And that is all you need to make a line. And a line is just 2 vertices. And then I do GL end, and I even put in a GL flush there. So, like, one thing could be like that it's getting rendered over, like something is rendering on top of it. But the only thing we're rendering, there's this outline thing. I guess I'm not sure what the outline is. But there's the GUI, that shouldn't be a problem. We actually want the GUI to render on top. Well, I am completely stumped right now. Let's try like just commenting out a bunch of rendering code and see what happens. Right? Like make the problem simpler. So like I am going to comment out all of this stuff here. Oh, can we not do nested comments in C? That is really annoying. So I guess we're going to do an if 0. I will give that a try. Thank you for the suggestion. So I guess I will wrap these ones here. So here is our simplified invalid operation GL end. Interesting. It would seem you were onto something, Tiberian. We do have a problem. So why is GL end an invalid operation? So this is saying that we don't want to use GL get error inside a begin end block. So let's put a GL check on the flush. So I don't think that was, I think that was a false flag, right? All these invalid operations. It was just complaining because the macro is calling a GL function that isn't meant to be used in there. Another thing that I found interesting though is that the brushes and the layers, like that's still rendering. And that's rendering on top of the canvas. So where is that rendering happening? Because it's obviously not something we commented out. Let's comment out all of this stuff and see what happens. So I'm gonna say if 0 So those are still rendering. Our canvas, of course, is not. We don't see our line. No, I don't think it's because of them being deprecated in later versions of OpenGL, although that might be true as well. I think the problem is actually that there are limits on what you can call between begin and end. So I'll show you the documentation here. So it says only a subset of GL commands can be used between GL begin and GL end. The commands are vertex color, secondary color, index, normal, fog card, text card, multi-text card, vertex attrib, eval card, eval point, array element, material, and edge flag. It's also acceptable to use call list or call lists, but that's it. So the GL call that we're doing in the macro to get the error is not legal between GL begin and GL end. I believe that's what the problem is. So I'm really confused about the rendering pipeline here because we call GPU render right at the end here. And there's additional rendering happening because the only thing we're doing in that function right now is trying to draw our custom line. So I wonder what's calling this function. So this is Milton update and render. So it's called on line 975 of sdlmilton.cc. So I want to take a look at that. Okay, so we do call the IMGUI render here. So that explains that. But I'm still wondering why our line isn't drawing. Also, we're just about out of time. So I think we're gonna have to call it a day here. And hopefully we can make better progress tomorrow. So I'm just going to go back to the file we were looking at here. And I guess that's it for today. So thank you for watching. And of course, thank you everyone who watches on the YouTube archive. It's available at risc-v. That's a quick way to get there. If you want to catch the stream live sometime, there is a Twitter account at HMN_risky, where you can go to get updates on when I stream and everything else related to risky business. So stay risky, everyone.